Welcome everyone. In this video we're going to explore the transformations of quadratic functions. We have the basic quadratic function is y equals x square. In this video we're going to see how we can transform this equation, this quadratic function, to another quadratic function of its standard form y equals a x minus h the whole square plus k. So this is the turning point form or the standard form of the quadratic function. There are three different kinds of transformations that can occur to the standard function to reach to this function. Okay, so they are reflection, dilation, and translation. Okay, so these are the three different transformations that can occur to this basic quadratic function to reach at this general function. Okay, any quadratic function can be transformed this way. Okay, let's first look at reflection. In reflection, what we're going to basically look at is if the function, if the parabola is the basic shape of a quadratic function, if it's concave up or concave down. Which parameter is determining that feature? Okay, let's look at two functions. The basic function y equals x square. So that looks like this. So if we plot the function y equals minus x square, that's exactly the same function but reflected parallel to the x-axis. Okay, or it's like a quadratic that has been flipped upside down. So the sign of this variable a before this x minus h the whole square determines whether it's concave up or concave down. If a is positive, it will be concave up, and if a is negative, it will be concave down. Okay, so we can look at the shape whether it's a concave up or concave down, but just looking at the sign of a, even if it's a y equals 2x square and minus 2x square, minus 2x square is just a reflection of 2x square above the x-axis. Yeah, I hope that makes sense to you. And now let's look at the next transformation, which is the dilation. Okay, so the dilation determines whether the graph is narrower or wider. Let's look at three different graphs of the functions y equals x square, the purple one, and y equals 3x square, the red one, and y equals half x square or 0.5x square, the green one in the graph. So you can see that this y equals 3x square is narrower and y equals 0.5x square is wider compared to y equals x square. So what is different in these different functions? So if you compare this with the standard form, a is the coefficient of x square. H and k are 0 in this case, and the a is 1 in here, 3 here, and half here. So a is known as the dilation factor, and that determines whether the graph is narrower or wider. Even if it's reflected, if the 3x square, that will be narrower and closer to the y-axis compared to y equals minus 0.5x square, which is wider and away from the x-axis. Okay, it's just reflected. Okay, so the numerical value is the only thing that matters. It doesn't matter whether it's a negative or positive. The numerical value, if it increases, it will be narrower, and decreases, it will be wider. Okay. Now let's look at the last transformation, which is translation. There are two different kinds of translation that can occur. One is vertical translation and another one is horizontal translation. Let's first deal with vertical translation. In the turning point form or the standard form, k determines the vertical translation. Let's look at three different graphs of the functions. Y equals 2x square, which is the purple dotted one, and y equals 2x square plus 5, which is the red one, and y equals 2x square minus 3, which is the green one. What do you see as the difference in there? 2x square plus 5, it translated upwards by 5 units, and 2x square minus 3 is translated down by minus 3 compared with this one where k equals 0. So the k determines the vertical translation. If k is greater than 1, it's translated up by that many units. And if k is less than 1, it's translated down by that much amount. Okay, now let's see what is the horizontal translation. Okay, how can you determine whether the graph is horizontally translated? And horizontal translation is determined by h. Okay, let's look at two different graphs. Y equals x minus 1 the whole square and y is x plus 2 the whole square. And this is a green one there and this is a red one in the graph. What is the difference? This is translated to the right by 1 unit. And this is translated by 2 units to the left of the graph. Okay, so how can we compare that with h? So what is h for this equation? So h is positive 1 because you have to compare this with the equation x minus h. So the h is 1 here and h is, this equation can be rewritten as x minus 2 the whole square. So the h equals minus 2. If h is positive 1 or if the equation is x minus 1 the whole square, the graph is translated to the right by h unit. And if h is negative or if the equation is of the form x plus something, that's when h is negative, the graph is translated to the left by that much unit. I hope this makes sense to you now, the reflection, dilation and two different kinds of translations. Okay, let's do one question. Identify the transformations for this equation y equals 2x minus 2 the whole square plus 1 from the basic quadratic function y equals x square. Okay, let's look at different transformations possible and see which has occurred for this one. Okay, first of all, a reflection. So reflection is determined by the sign of I. I is 2 in here, which is positive, so that means the graph is still concave up. So there's no reflection occurred compared to this one. Okay, so no reflection. And let's now see if there is any dilation, whether the graph is wider or narrower than y equals x square. That's determined by the size of I, the numerical value of I, which is 2 and it was 1 in here. That means it's dilated by a factor of 2 from the x-axis. So the graph is looking like the red one where it's been dilated or the values of y is a little bit higher up compared to that in y equals x square. Okay, it's more and more closer to the y-axis. Okay. And so that's happened. And the next one is the translations. And the two different kinds of translations are vertical and horizontal. Let's first check whether there's any horizontal translation. Okay, that's determined by the value of h. Looking at this one, comparing these two equations, we can see that h equals 2. If h equals 2 or if this is x minus 2, so that means the graph is translated to the right by 2 units. Okay, so now we have applied two different kinds of transformations, dilation and horizontal translation, and the new graph is the red one. Okay, we're going to now apply the vertical translation if there is any. Is there any vertical translation? K determines the vertical translation and which equals 1, so there's definitely a vertical translation has occurred. So k equals 1 size, the graph is translated upwards by 1 unit. So that's the new transformation applied to the graph, and you can see, and the red graph is the new transformed graph from y equals 2x minus 2 the whole square plus 1, and the basic quadratic function is also shown, y equals x square. I hope this makes sense to you. So you can do as many examples as you can to emphasize these concepts.